G'day, welcome back to Brupeg. Today's episode is about getting our bilge pumps into the boat so that we can get our insurance list signed off and get our survey, get our boat rego, and get the boat launched. It has involved some blood, sweat, swearing and tears to get these damn things in. I wasn't expecting that to happen. I want to say thank you for our Patreons, people that have donated on PayPal, our viewers and our channel sponsors. You guys really make this possible. This is probably the most expensive time of a boat build, getting a boat launched. It's where all of the costs happen and you can't necessarily build your way out of them. You have to buy stuff like rego and insurance and things like that. So because of you guys, this has actually been possible. Thanks very much, guys. One of the stars of today's show is my German friend here. I've just noticed there's some instructions on this we probably need to pay attention to. Obviously we need to make sure the Smuts and Wasson pump for specialised Wendon dungeons is taken care of when we install this. Exciting day. I'm pretty pumped. What are these guys? So we have to mount this engine driven pump and also this electric 240 volt float switch pumpy doodaki bore pump. First job on the bore pump is to take the bottom off and actually glue that down to the very bottom of the boat so that it can't move. Let that set and then we can carry on with the rest of the install. So there's the base. When you remove it, that's what you got. That's your impeller. So basically centrifugal force fires it out to the side, and then just with the shear shape that's moulded into this here base, it gets fired out that port. I think it's 1.5 inch diameter port, I think. So what I need to do is actually glue this end down hard onto the bottom of the bilge. So I'm just going to completely encapsulate that in a sealant, an underwater capable sealant, and then that is going to be my mount. If you're after an absolute bulletproof adhesive for anything boat, I'll show you the stuff that we use. We've got a chandlery over the road that stocks it. It's an Aussie made product. It's absolutely amazing, this stuff. It doesn't smell compared to a lot of other products, but the strength that it has and the capability that it has is just second to none. We're going with 190 today. This is a high-tech adhesive that can be underwater, so let's get this in the boat. Righto, glued.
What's it called, a forklift?
A helper to drive the forklift, and you just pull.
If you yank it from the end, it'll just fly out.
Yeah,
just watch your feet.
Yeah.
Move fast.
3, 2, 1. All right.
Do you want to take an end each?
Oh, let's put it on the dolly.
Oh yeah. This is our spare anchor, Danforth sand anchor.
He's the fourth in the line of Dan's.
It's the design that distinguishes it as a Danforth.
Yeah, so you got your central shank and 2 flukes, and they generally sit pretty flat, so you can see like there, when the shank's sort of in the centre, they're really narrow, so they're great for stowage. They store away really easily.
Yeah, really lovely. And this is 120 pounds?
Pound, yeah. So it's, I think.
What's that kgs? So that's what, 60 kg?
Yeah, 60 kg. Just a wee one.
You can't see this on camera, but it's really uncomfortably humid. It just kind of makes work
there we go.
a little bit more tiring. You got to hydrate a bit more. And that's where our winch is up top, so we'll just leave it there for winching later. I'll just tip this up. I can't talk.
Jess let me know that she wanted to modify the trailer a wee bit when it rains. we get a big puddle of water down in this corner here. Doesn't drain that well, so she said I'm planning on putting a bit of drainage in it today.
There are some things on this project that for me were really annoying, and this was one of them. So this is an enjoyable experience for me. In a few minutes this won't be here, and that heralds the coming of the end. Or at least hopefully launching. It's like a portable sauna today.
Should we get into the trailer? Right.
I was thinking of cutting these off and opening this up.
Yeah, just
sliding that out and then chopping straight through. What do you think?
Yeah, definitely. So that might be fun. Trying a sledgehammer to whack that.
Have you got one?
I've only got the little one.
You're gonna have to do it for me.
Right.
Woo!
Is it held? It must be screwed on.
Yeah, I think so.
It's probably screwed on the underside. I think there might be angle on.
It's holding on.
There's a little bit just there that's not cut that's holding it.
Baby, what you put me through, nothing but a strike of thunder, are gonna hit me from the blue. You make me weak, baby, I can't sleep. Yeah, baby. No, I can't sleep, I can't sleep no more.
Something very satisfying.
I'll just fold this one up. That way the person that reassembles it can just unfold it.
That's right.
Yeah.
How civilized and...
Side of a good workman. Okay, 3, 2, 1.
Oh my God.
No, it's not aiming. We might have to lift and winch because I'm not sure
Yeah.
it's got enough juice left in it.
Yep. Hope that thing doesn't land on your head.
Yeah. Keep going. Wait. Okay, and okay, ease it down. Keep going, all the way, all the way. Okay, wait, stop. Okay, we should be able to control it easily down now.
Woo!
Done. Nice.
So I was thinking maybe just cutting these, eh?
The rust on that side almost gave way before you cut.
Yeah. Voila.
Voila.
It's heavy, isn't it?
It's waterlogged. Okay. This rust is structural, it's got sicker on it.
Trev would be pleased. Woo! And now, back in the bilge.
With a wee bit of light on the scene, you can see that the 90-degree fitting has been put in there, the O-ring's in there, and it's greased up, ready to go so that it seals up without any drama. The base is glued down, you saw that just happen. It's been in there for half a day, so it's not fully set, but it'll be close. So we just clamp this down with the 4 Torx head bolts. We can plug this in and actually see if it spins if I lift that float lever, the big test. While we're down here, I'll introduce you to some of the main characters in Brupeg's bilge. So, we have a bunch of different fittings on the bulkhead here. This stainless cap, that's a 1.5-inch port that just goes directly through into the freezer room. It was in use when the boat was a fishing boat, and that was a freezer room, and we don't need it, so we've just basically blanked it off. I don't want to get rid of it because we may one day decide to use it for something, but for now we've just basically capped it off so that it's not going to be an issue. These 2 guys here, these are 2 stainless pipes that run from the engine room right the way forward into the starboard and port fuel storage tanks. So this is obviously starboard, this one here is port. They go through the water tanks and into the fuel tanks. Bit of an odd setup, but yeah, that's a heavy wall stainless pipe all the way through. We've checked and sandblasted and everything, so they're all in spotless condition, so they're going to be used to transfer fuel around the boat. This big 2-inch pipe here, that's actually the bilge clearance pipe for the freezer room. So there's a sump in the freezer room, a stainless sump, and everything goes down into there, and that pipe there goes down into the sump. So we'll be connecting our, you can sort of see here we've got a threaded 2-inch lid. That 2-inch lid is going to be basically connected to a fitting that goes to our 3-way valve that then goes to our engine pump. So we can pump out the freezer room using our engine pump. Brupeg's bilge system is going to be electric as well as mechanical, 2 separate independent systems. The electric is going to be on that float switch, so if ever there gets to be, I don't know, 1/2 foot, 3/4 foot of water in that bilge, that main green pump is going to come on and start belting it out over the side. There's obviously it's not going to get that sump completely dry, but it's going to definitely keep this room dry. If we have more water than that, we can fire up the main engine and start that main engine driven pump, and that's able to suck from either this room or from the freezer room in front of this bulkhead just here. So that's the next step, is putting that engine pump on the Cummins. I need to use this mount, which is off the old alternator, and I'm going to mount my engine driven pump off this here. So time to build a bracket. Wouldn't be Brupeg if we weren't doing it out of stainless, so have a couple of bits of 6mm stainless plate that I'm going to use. It's also swelteringly hot. I don't know if I've mentioned it before, but sometimes we get a bit of rain, so yard floods out and all that sort of stuff. I built a bridge so that I could get over it. I don't know if there's sweat pouring off me yet, but it may appear in some of the future clips. The bracket that I need to make is 100mm wide. This is a piece of 100 by 6mm stainless flat, so I'm going to use this as the basis of it. I was going to use this 50 by 6mm as the little pieces that get welded on with a hole drilled through to bolt onto that bracket, but on the ground I found a couple of pieces. I can't remember what I cut these off, but they're going to work out perfect. So I've just rounded off the corners on one end. They had the wrong side rounded off, so I've rounded off the right one, and I'll weld those in like so, one on each side like that, and that there is going to be basically perfect for what I need. So in order to make those two work, I need to drill a 13mm hole through them. So I've got a 5 and then a 13 just to knock through it. Come on, come on, come on, come on, come on. Hey, lovely. Right, 2 of these cut. Let's take this up. We'll take it onto this guy here. Actually, let's clean it up in the grinder first so that it's a whiz-bang weld. Weld on. I'm about to TIG these up, but before I do that, I want to show you something. This torch belongs to a SIG Weld TIG welder. This little guy over here, this was donated by Jason Ziegler. This thing is awesome. Just going to turn it off so that it's not so noisy, but it's basically a high frequency TIG and stick machine. So it can do lift TIG, stick and high frequency TIG. I've never used high frequency TIG before, and it's absolutely bloody awesome. So when we were going through the drama of our Unimig welder when it had a fritz with the circuit board and that got replaced under warranty, we went and bought another little welder. That's the little wee purse welder I showed you a couple of episodes ago. But in the meantime, Jason has donated this thing, and it's hands down, it's awesome, man. It's probably even better than our big main Unimig welder when it comes to TIG welding. So yeah, we're keeping this thing at close hand because we're using it all the time at the moment. So yeah, absolutely thank you so much for this, Jace. It's just a beast of a machine. All right, TIG time. Bolt this on and tack it up. I need to slice that corner around there with a bit more sort of angle. That corner there is bopping into the bracket just in here. I can't actually rotate it. Minor modification created. That's something I didn't anticipate, because this plate is skinnier than the old brackets that were on the aluminium housing. Okay, what does fit is a couple of old banjo fittings. I'm just going to throw them on as basically spacers to take up the gap and then tack it together. It's just the right level of tungsten stuck in the weld. That's perfect. While that cools down, I'm going to build the adjuster. So this is the old adjuster from the alternator. So you've got the fixed point here, and you've got a slide here where you can basically adjust the alternator in and out. Pretty common on older cars that you could just stick a crowbar or a lever down, pull your alternator out, and then tighten it back up, and that adjusts your fan belt or whatever, alternator belt, whatever it may be at the time. I'm always a bit skeptical of subjective things like that. Like, it's either slipping or it's not, I get that, but it's still, I don't know, I just don't like it. It's so much easier to do a threaded adjuster, so that's what I'm going to build today. So I've got a piece of threaded stainless rod. I think this is 1/2 inch stainless rod, and the equivalent rose joint, ball joint. So if you've never seen one of these things before, basically what it is, you've got a thread at this end so you can join onto, you know, threaded rod or whatever, you know, internally threaded bar or something. But at this end here, you've got essentially a ball bearing with a hole drilled in it, and it can move around on a brass bushing. So the cool thing is you can put, say, a bolt through your rose joint like that, and then the rose joint can move through any position, doesn't matter where it goes, and it's completely encapsulated and there's no slop in the system. So it's an awesome way of doing like a mount that has to adjust, and every time it adjusts it's changing its angles. Rose joints are great for that. They're not very expensive, I think this is like $6 or something like that. They're pretty cheap. But my plan is to join this threaded rod to my rose joint. So I'm going to use a piece of stainless angle just to basically get them centre to centre. It's looking a little bit more compact and different now. We've basically got the threaded bar trimmed and rounded off, so this end is nice and domed, so if you hit it, it's not going to stab you so much. I've got a bracket here out of just some angle I've cleaned up that I'm going to use as the adjuster. It allows quite a bit of travel, so more than enough to be able to keep these belts tightened. So that's maximum extension there, and that's minimum. So we'll probably start with something like that just off minimum, and then we've got basically, I don't know, 2.5 inches of travel if we need to adjust it, so heaps more than what we need. I'm about to take all of this off and TIG it all together. I still haven't quite figured out exactly where I'm going to place the pump, because what I'm struggling to find out, like, I've got the bracket parallel now, so I've cut this off and welded it on a couple of times just to get this absolutely bang on. I'm happy with that, I've got that now. But in terms of alignment this way, without the belts, I'm struggling to be able to get the, you know, alignment exactly the way I need it. So what I'm going to do is pull this off and TIG it all together so that it's ready to go. And in the morning I'll nip into town and grab a couple of belts, and that'll allow me to then basically mock it up as it's going to sit. I'll clamp it all together as it's going to sit, and just sort of put a square over it, put levels and lasers and things like that, and just make sure it's as good as I can get. The challenge is if you get it wrong. So if these belts are slightly misaligned and for whatever reason, you know, like slightly twisted, or, you know, one's got a slight bend in it, or, you know, anything funny, if that's going on, these belts will start to shred themselves. So they'll wear out on one side more than the other, and then eventually they'll lose strength and they'll just break. That's the sort of, you know, the negative side of it. You'll also get just lots of belt wear. If it doesn't break, you're just going to start chewing through a lot of belts, and they'll get noisy and they'll start slipping and that sort of thing. So it has to be right, and that's why it takes, like, a bracket is easy enough to make, but this isn't just any bracket. It has to be absolutely perfect, and it has to be adjustable. So that's why it's taken me all day just to get to this stage, and it's just because I had to keep cutting it, modifying it, twisting it, aligning. Yeah, so anyway, we're nearly there. We'll get this tacked up, and then we're ready in the morning to nip in and grab these belts, and then go and, yeah, start lining it up with those guys. So these are my bracket welds. I'm getting happier and happier with my TIG welding. I'm starting to get the hang of actual stainless TIG. Still not Instagram quality, but it's not going to fall off. That one's got a wee bit of oxidation. You can see the colour's a bit grey. And that one's a wee bit blue. Colour's a little bit blue. But you can sort of see at the end here and at the start here, it's the right colour, but a wee bit of overlap from that back weld. And then happy enough with that profile. And over here, clear enough. They're going to be alright.
Changing fast.
You'd never believe this, but it's another rainy day. So I'm heading back into town. Jess and I are going to drop off a bunch of scrap. So the old trailer, that's getting recycled. And I'm going to go swap some fittings that I bought for the bilge pump. So what I want to do is actually put bigger pipes on. When you've got a suction side of a pump, you kind of want to have the pipe as big as you can so that there's the least amount of restriction on that side. The outlet's different. You can change the outlet and have, you know, like a bit smaller and a bit more restricted flow, because the pump's got the ability to force it through that pipe. But when you're sucking, you kind of want to go as big as possible. So I'm going from 1.25 to 1.5 inches. It's not a huge jump, but it's bigger than what the pump is. The pump's I think 1 inch. So yeah, I just want to do that so that I've got a bit more flow. The other thing I need to do is get a matched pair of V-belts. So V-belts normally aren't matched, so if you get two identical belts, they're going to be different lengths. It's just how they roll. Matched belts are a thing, but they're harder to get. So I'm not 100% confident that I'm going to be able to get matched belts, but I'll definitely be able to order something in. So that's this morning's job, is to solve that. This is Jess's wild weather shopping attire. Dressed like a lady up the top and like a farmer down the bottom.
While we were dropping the scrap off, it started spritzing a little bit, which was a fun way to unload scrap from the back of the ute.
Right, time to go and see if we can get these belts from the parts supplier in town. We have them. They're 5mm difference, slightly shorter, 5 by 5mm, so 2.5mm by the time you double them over. They'll do. That'll get us aligned up.
And one more stop at the agricultural shop so I can get the enlarged inlet pipe fittings.
With that done, we've got our pipe. We've got two sizes. We've got the big stuff and then the smaller stuff. We have changed the size of the strainer. Gone with the biggest strainer they had, 2 inch. I have the pieces that I need to do the outlet for the pump, the engine pump, and then I've also increased the size of these hose tails on this T-fitting. So we should be good. Given that we're in town, it would be rude not to go to the cafe. This is a place we go to sometimes, and they have this big fish that Jess likes. Big fish. Is it a bug? I don't know. Floating stegosaurus. It's quite cool. Underarms are a bit hairy. It's happening again. I'm getting a bit nervous about how wet this is going to be when we try and put the boat in the bay. If it's too wet, we can't paint. So there's the risk that we go into the blast bay and we literally can't do a thing. It's bucketing down for the 3 weeks or 3.5 weeks, whatever it is that we're in there, and we can't actually paint. So if that happens, it's essentially $4 that's been thrown away. So I'm getting pretty nervous because we're getting close to that time where we're going to be going in there. You can see the adjusting rod is essentially in its position where it's going to be mounted. The bracket itself is welded, polished. The edges have been rounded off so that there's nothing too stabby on that bracket. I forgot to get a big bolt. I was supposed to get that in town and I forgot. Oh well, we'll use what I've got. So what I'm going to do now is start figuring out the plumbing, but also the belts. So the belts probably is the first thing I'll do. Once I've got that aligned, then I can start drilling the holes that go through to mount the pump onto the stainless bracket. Once that's done, then the plumbing itself. With the increase in pipe size, I should be able to get a bit more flow because it's less restricted on the vacuum side. I've got reinforced pipe so that it doesn't squish down when the vacuum, pulls some pressure, some negative pressure on there. It doesn't sort of pull it down small. Yeah, like the pump itself is only 1 inch inlet and outlet. So that's going to be probably the limiting factor. I just want to try and make sure that the pipes themselves are as big as I can get them on that vacuum side. I've gone with 1.5 inches on the outlet, so it's still bigger than the the pump itself, but it's just a smaller, easier pipe to manage. So I'll get that built as soon as I've got these belts on. Oh, I remember why I didn't like this front mount. Okay, there's a slight issue with these belts. This engine mount is very, very difficult to get belts on and off. And that's not something that's a great design maneuver, but it is something we have to factor in. I wonder if I can unbolt the balancer. Hey. One day I'm going to modify this front mount so that I don't have to take this balancer off in order to get V-belt replacements on there. But it ain't going to be this day. I've got way too much to do. Right, well I didn't actually expect all of it to come off. That's my solution to getting them on right now, is put them on, zip tie them together, and then bolt the whole thing back together with them dangling out the side. Good crikeys, that's heavier than it looks. Let's get some bolts in it. Hey, there we go. These need to be torqued up. I don't know what the torque number is. I'll get that out of the manual shortly. But the other reason why I'm not going to bother torquing them up right now is because I don't know if this is going to come on and off again. And the flip side is my torque wrench is 1/2 inch drive, and the only socket I have that fits this is 3/4 drive. So I'll grab an adapter next time I'm in town. And then, yeah, once I'm on the final nip, I'll go and tighten these up with the right torque. But for now, just in case I forget and start the engine, just give them a zip. Oh, collective click click. Right, my bracket is complete. I've increased the clearance in this hole. This hole was a 13mm. I've bumped it up to 14mm so I can tip the bracket further back. This is a 12.75mm rod, so 1/2 inch rod. The reason why I had to tip it back is these belts are slightly too short. So these are 1335mm is the circumference, 1.335 meters. And they're too short basically, so I've got another pair on order that's 40mm longer in the circumference, so I'll be able to bring the bracket out slightly. It doesn't change the alignment will still be the same no matter what. The only difference is when I bring this back out, this edge of this angle comes further and further away from the belts, which is what I want. But what I'm going to do is just set it up with these belts regardless, and then put the new belts on and adjust it out. These are not a matched pair, and I knew this. But I bought, they're pretty cheap. I think they're like $7 or $8 each. I bought them so that I could just do the alignment regardless. So my plan is to basically get it all plumbed up and running and working and everything, and then just swap the belts over when they arrive in a week or so. All right, there's our alignment holes. I was thinking about this bracket. There's no reason why I can't put studs, weld some studs on the back side of this bracket so they stick out the other side, and we can easily use them to align the pump. So I'm going to do that. I'll weld one on, get the pump aligned, and then nip the other one up tight, take the whole bracket off with the pump and tack the bolt in the right place. So that's how I'm going to do it. God, I hope it works. What this is the after result of carefully setting the camera up and then forgetting to turn it on whilst I welded it. Okay, so this is going to be level 5 nuclear temperature. So, you know, don't touch, Damien. Alright, good. So far, so good. Bolt out. Just like that. Now, bolt on. Something like that. Right, let's get that on there for now. Oh, come on. You're not going to fit? Serious? Because it's bolted on? Seriously. There we go. So what I'm trying to do is find where this lines up, and I think I've got that. And then I want to nip this bottom bolt up tight and then tack it. And that way I know that this pump essentially has studs that can just go on it. So whenever you need to take it on and off, it's always going to align. It also means that all of the bolting up side is on this side, so it's easy to get to rather than having nuts and washers and stupid things behind the bracket. I'm confident that that alignment is going to be good. I can't see any twist in any of it. The belts look quite flat when it's pulled tight. I'm pretty happy with that. I may need to trim this corner off. In fact, I will need to trim this corner off, but with the longer belts, that's also going to come out, and this will come away from the belt, and this surface will be flatter on the nut. I might make like a rounded, like get a piece of solid bar, cut it in half, drill a hole through it, cut it in half, and have half on each side so that it's always able to rotate. This one here has been tacked in, and this one is now bolted up tight, so I know my alignment is correct on the bracket with these two bolts. So if I just tack this one in, I don't want to put too much heat in because I don't want to transfer it through into the pump. I just want to basically tack it one on either side and then take the pump off and then weld this one in properly. After a wee bit of swearing, a little bit of welding, some measurements and some bolt tightening, I think we are getting there. The bracket is fully in place and everything is tightened up. We can adjust it with the thread. The belts are nice and tight. Even though they're not a matched pair, they're still both really tight. So that's cool, that's a good sign. Right, now I'm going to start working on this plumbing. I was hoping to have been doing that in the morning, but never mind, let's get into it. This is the inlet and this is the outlet. What I'm thinking of doing is connect this like so and hook that back on there, either behind the pump or off to the side. I think probably off to the side because then I can always access the impeller, so I don't actually have to muck around with any of the pipe work. So we've got an inlet that's 1.5 inches diameter. We've got an outlet which is 1.25 inches, and the way that I positioned this top outlet, doing it sort of U-turn and then heading back down, it means if you come around this side you can access the back of the pump at any stage to change the impeller. What I'm going to carry on with now is figuring out where these pipes actually go to, so let's get the inlet sorted. In order to get the pipes done, I need to mount this thing. So this is going to be our directional valve to figure out if we're pulling water from the engine room or from the freezer room. Now, I don't know of like a bracket that you can buy that just holds these, that you could bolt the bracket to the wall or something like that. My God, that's a brilliant product if someone should come up with it. I was thinking if I knew how to 3D print one, I'd make a 3D printed base thing to hold this. It would be awesome. But I don't know how to do that, and I don't have a 3D printer. So what I'm going to do, make something out of metal, because I do know metal. So what I'm thinking, 25 by 25 by 3 stainless angle. My thought is cut it roughly the same length as those two hose tails. You can see the black mark there. And what I'm going to do is trim off the sides and bend it up and do all sorts of stuff, and then I'm going to hose clamp it, put the hose tail and everything on it, put the hose on the hose tail, and then clamp around, one clamp going onto the hose and one clamp going onto my metal bracket, and then that is going to be welded to the wall. So hopefully this will be as solid as. Yep, I was getting rained on. Okay, I just need to make those edges a bit round. Oh, there! I think we're getting somewhere. I've put some of the rubber hose that I'm going to be using on to work as an analog. The first model that I made wasn't quite complicated enough, so I've basically chopped out a piece to allow for this round here, and I've also, you can see that I've also added some little wings, some lifts on that wing there. So when I put that against the wall, I think that's going to work. The next question is, where do I even put this selector valve? Logic would tell me that you'd want the pipe distance between the pump and the pickup to be as short as possible. So, okay, cool, we'll go with that. Keep it as short as possible. The next thing is, don't put it in a position where you can boot it every time you walk past it. Alright, that narrows it down. It's getting late in the day and I forgot to press record. That's where the little mount's going to go. And the valve itself will sit like that. Obviously we'll try and tidy it up a wee bit so it's not so far out in the walkway. And I'm also going to straighten that handle, that big kink in the handle. I'm going to get rid of that. Day 5, I've definitely got this. I'm like 60% confident I'm going to get the job finished today. Where I got up to last night, the pump is mounted, we have the inlet and the outlet ports on, the belts are aligned, the bracket's done. This 3-way valve was mounted. What my plan is now is to start running the pipes. So I'm going to start with the intake, so it goes from this port here across to this port here. and I've got a few holes down the front of the engine here that I can start running pipe work through. And I have two different sizes of pipes to work with as well, so I've got 1.5 inch and 1.25 inch over the back, the 5 meters of 1.25 inch and 10 meters of 1.5 inch. 1.5 inch is my pickup, so that's what I'll start working on now.
Hey, he's got me looking quite beige, got me deep in the haze. There's no more compassion, no. Raise me.
Right, pump to valve intake is done. So I've sort of kinked out my cable tray down here. I will put some chafage protection and some things to hold the pipe, but it goes underneath the floorboard along the bottom of the engine room here. Ignore this cable here that's just in the way, but that comes up and goes into the pump. Now I will be putting chafe protection on this area here. You can sort of see down there, this touching the steel at the moment. I will be dealing with that, and same down where it goes through that bulkhead there. I will be putting something around that bulkhead to protect that pipe. So that's yet to come, but what I do need to do now is start working on the other pipes for this valves here. So I've got this port on this side here, a left-hand port, goes down to that big threaded pipe there, and that follows through and goes through the bulkhead and into the freezer room. So that's how we pump the freezer room out from this side of the bulkhead. Now, in order to connect a 1/2 inch pipe onto what is a 2-inch thread, sorry, a 1.5 inch pipe onto what is a 2-inch thread, I've got a 2-inch lid, 316 lid. I'm going to screw that on top, but I'm also going to put a hole saw through the middle of it and then chop the thread off this guy and TIG it on, and that's going to give me basically a 2-inch cap to a 1.5 inch hose tail.
All this fake news, tell me, what is the use? Tell me, there's no more compassion, no.
That's what we're left with. Right, let's go and join that on. You know how boats are always a work in progress, there's always a job to do or something to improve. This tank that I fitted a couple of weeks back, so far I've smacked my head on that corner there, quite solid whack, and I've smashed my shoulder into that corner there. So I'm just letting you know that on the to-do list, buried at the bottom of it, there is an upgrade to this tank, round the bloody corners off. I'm just going to join these together. I love welding 2 bits of stainless like this. It's 2 bits of 316. You don't even need filler rod, you can just basically zap it all the way around and just melt the two of them in together. I'm going to double continuous because I can actually get into this side of it, so I'll tack it on this side because then I can get it perfectly centered, and then I'm going to flip it over and buzz the outside, smash it out. Let's get it done. Right, while that's about 1,000 degrees, I'm going to go and do something else.
Now how big is your love? Tell me, how high is your patience? Can I be saved? I wanna catch the wave.
I'm not 100% certain this is going to work, but my idea is 1 T-clamp for the hose and 1 T-clamp for the mount. I've got enough in that hose tail to be able to do that. The hose tail is quite long, they come out to about here somewhere. You can sort of see over here, they are, you know, you've got almost 2 inches maybe, so these are less than 1 inch, so we should be good with that. But what I'm thinking is basically double that, put that system over here as well, and that's going to hold it in really tight against that mount. I'm hoping that that's going to be enough. I was thinking I might need to do another one down on this 3rd leg, but I think I can probably get away with 2 because I think it's going to be pretty rigid. And then obviously we'll clean everything up and we'll write, you know, like engine room bilge, freezer room bilge, or whatever it happens to be. We'll basically write that all on the wall so there's no mistaking. You can also see I've straightened this lever out so it doesn't, you know, stick out into this walkway much. I've saved about 1 inch by doing that. So we have lost, I don't know, 5 or 6 inches probably in total in this area here, but I think it's the best position for it. That came up all right. Pretty simple. Not the prettiest weld in the world, a wee bit grey, but that's definitely not going to come apart. And then same deal on the inside, it's continuous welded right the way around. As Barry White once famously said, let's get it on.
It turns out this little piece of trivia that I had tucked away in my head was completely false. Barry White never said that. Marvin Gaye did.
This is my strainer for the bilge pump. So the engine driven pump is going to be pulling water from this basically stainless grate here through this. This is a 2-inch grate through this 2-inch to 1.5 inch reducer and then onto the pipe. So essentially the suction starts from this part here. What I'm hoping to do is be able to actually just push this into the bottom of the bilge I would love to glue this down, but I also am aware that the pipe is probably going to break that glue. I'm not 100% certain how I'm going to hold that down into the bilge. I might have to build some sort of bracket. For now, I'm actually just going to push it into the bilge as low as it can go and just sort of see how it works. It's probably not ideal. I would love a metal bracket, but I am starting to run out of time. It's, what are we now? Late Tuesday. We normally finished our footage by Sunday, so I'm already like a couple of days overdue. This has been a massive build, the amount of work involved in this, and I'm probably still going to be going until late Thursday. So I work during the week, Tuesday, Wednesday, Thursday, and then so a couple of hours in the morning if I'm lucky, normally an hour in the morning and an hour or two in the afternoon I'm able to get into the boat. So it's one of those compromises I don't like making in terms of like not doing it as good as what I want. But I think it's good enough to pass what we need to do and I can tidy it up later. That's why I'm happy to sort of just see how we go. And if the surveyor says you need a bracket, I'll put a bracket in. Right, pipe connected, time to fit this to the valve. Okay, now we've got the bulk of the pipelines done. We need to sort the outlets. So we've got one from this green pump here that goes from that fitting at the end of the base, comes up along the wall, etc., follows along this part, goes vertical and goes out that little hole there. Now, that's a pain in the neck to get to. It's tucked behind shelves, it's a weird length and so on. So I have to come up with a solution for that one. That's the electric pump. The outlet for the engine pump on this side here goes from this fitting here. It'll drop down, follow the bilge sort of up to about there somewhere, and it'll have a discharge somewhere around there out the side of the boat above the waterline, but just with a traditional Seacock skin fitting. In the interest of saving time, I'm just going to use a standard Seacock skin fitting with a nylon 90 and a hose tail. Pretty fast, pretty easy to put together, and I don't have to worry about electrolysis. Sticking with tradition, not one part of this job has gone easy. Let me show you what I'm working on now and my solution. I'm working on the pipe that goes from the green pump up the side of the boat and to the skin fitting that's over here. If you have a look there, there is a large spanner attached to a lid. That's a skin fitting that goes out the side of the boat. Now that spanner is 2 feet long. I've put a pipe on the end of it and I've smashed the pipe with a sledgehammer and I still can't get that thing to move. So what I'm going to assume is that it's quite tight and I'm probably not going to be able to get it off. So I have an alternative plan. On the other side of the engine room, I'm going to drill some holes. I have these two stainless skin fittings that I picked up from the chandlery just a second ago. What I'm going to do is pop them up on the wall just over there. Well, when I say wall, I should probably mean hull. You know, it's a boat and all. What I was thinking is if I locate them two side by side, sort of like that in the hull, I can basically have the hose tail coming off, doing a 90 and coming off and going straight into the pipe. But I can have both of them sort of quite nice and neat and running down the side of the boat. It's going to look lovely. Probably way better than what it was going to be if I split them onto either side of the boat. With the holes drilled, you can see I've popped a little bit of paint around the bare steel so that there's no chance of rust underneath anything. I want it to be completely encapsulated. I need to go and mount these guys now. So 1.25 inch skin fitting, put a bit of sealant around them and then push it into the hull and tighten them up. Normally I would probably go and weld these in, but I'm out of time. I don't have the time, so I'm just going to do the normal thing of like standard fiberglass, timber boat, etc. Push it in with some sealant and then seal it up. There's no issue doing that on a steel boat. It's just, you know, there's other ways of doing it sometimes. So let's get this done and we can get these pipes connected. In keeping with nothing on this job so far has been simple, I don't have a ladder, so reaching the actual holes themselves is a challenge. But that's a minor issue. There's a massive big wing in the way. That stops me from getting the skin fittings in because it's quite close to the hull. So I have to cobble together a solution to drop that. We don't have winches that work at the moment. You may have seen in a previous episode they kind of destroyed themselves and we haven't solved that yet. But what I'm thinking is just cobble together something, take this green strap off. I've got that up there just as a safety, just in case. I'm going to take that off and maybe just lower it out 1/2 metre. Doesn't have to come all the way out, just enough to get these fittings in between the hull and the wing. Okay, you ready?
Yep.
Okay, can you give it a shunt?
I am, yep, it's moving.
With the wing cracked out slightly, I've got just enough working room to get these skin fittings in. So, time to start putting some goo around these. I'm going to use Fixtech 190. This is a below waterline capable sealant, and it glues as well as seals, so it's a pretty awesome product to use for this application. Bit of a race against time to get these things on, but so finger tight, and then we'll come back and do them later. I'm not putting sealant on the inside, I'll do that actually later. So the way that I like to do skin fittings is basically put them in with sealant on the outside like this, and then tighten them up finger tight with the big nut, and then come back afterwards once it's all set and undo the nut, put sealant on the inside, and then do the nut up sort of tight, because that'll squeeze the outside dry sealant tighter, and it'll also the second bead on the inside will make sure that you've got anything that you need to take care of done, if that makes sense. Right. You don't want to over tighten it because you squeeze the sealant out of the join. Alright, they are nice and solid, but we can start doing the pipe work now. People of YouTube, we're getting very close. This electric pump down here needs to have the outlet connected to the outlet on the left hand side over there, this one just there, and the stainless outlet on this pump here needs to follow around the bilge, go all the way up and go to the right hand skin fitting. Got a couple of things. I've just been into town. I have the matched belts, so we can get rid of these guys because these are not a matched pair. Even though they're tight, they're probably too tight. They're not a matched pair, so I'm going to swap those over. They're the permanent belts, and that also allows me to bring this bracket out a bit further, which I'd be a bit happier with. This is a wee bit too tight for my liking. So I'll do the belts first because then my alignment's going to be where I want it. Not that it's really going to matter for these pipes, but we are so close. I figured that this would be a simple job. Remove the balancer, put the two new matched belts on, tighten everything back up again, and we're good to go. That wasn't how it worked out. I took the balancer off. I put the new belts onto the balancer, put the balancer back on, aligned everything back up, realised that they were too sloppy, took the balancer back off, swore, got the old belts, put them back on, put the balancer back on, put the belts back onto the pump, realised that they wouldn't fit without disassembling the pump, disassembled the pump, put the belts back on, realised the bolt wouldn't fit, jiggled it around a bit more, pulled the actual pump off the mount, got the bolt back into the mount, rebolted the pump onto the mount, fitted the adjuster back onto the engine, adjusted the pump back up so that everything was all good, and finally tightened the bolts back up on the harmonic balancer so that we're back about where we were an hour ago.
Come on, come on, come on. Don't know what you do, but you make me feel fine. And you can't deny we are not just killing time. You should let me know if you want this true. Baby, you just make me feel crazy. A little crazy for you. Yeah.
So a trick that the surveyor told me about is that if you're trying to put a pipe on a skin fitting like this, or a hose tail on a pipe on a hose tail, put sealant on the actual hose tail and pipe itself, and then it acts like a lubricant to get it on, and it acts like a glue when it's on. So this is something that is not going to come off very easily, I accept that. But this is something that I don't want to come off, and if it does, I want it to be difficult so that I know that it's not going to come off by itself. Surveyors prefer T-clamps over Jubilee clips. Jubilee clips are garbage. These things are absolutely 10 times better. This is feeding the hose down with a threaded hose tail on it into the bilge pump. I'm just spinning the pipe round to be able to just spin the hose tail. And then once I've got it as tight as I can get it manually, I get the big spanner in and give it a nip.
A little crazy for you now. for you now, baby. I'm a little crazy for you now.
Long time ago I put a bung into this part of the Brupeg. This is a 2-inch stainless bung. This goes into the deepest part of Brupeg, into her soul, well, bilge. But what I need to do is crank that up. I've just gone, in the spirit of nothing going the way that I planned, I went to put the old one in and I realised there was all this welding slag all around it from some random job that we did over the years. So anyway, just nipped to town and grabbed another bung. It's a 1-hour trip, by the way. Now I need to just, I've got a little bit of paint and rubbish in the threads, so what I'm thinking, I'll just crank it up. I'll use some of this Loctite as thread sealant and lube. But when you have a bung like this, you want to basically put some thread sealant on like so, and then you want to, if you can, sandblast it and then anti-foul over top. But we'll do that when we're in the bay. We'll give this a blast. So I'm putting absolute shite loads in because I want it to seal like crazy, but I also want it to be lubed up when it goes through. Okay, that's good. You can sort of see how much I put on. It's like probably ridiculous levels. It's okay. I'm alright with that. Alright, here we go. It's going to lock up pretty fast. Yep. But I have the small spanner to use. Okay. Spin. Click, click. First test, we'll fill it up with water and let it sit for a bit. With that done, we can now fill the bilge up with water and see if it actually pumps it out. So until we've fixed the cooling tank hole and fill this up with coolant, I won't be starting the engine. However, the engine pump is ready to go. The electric pump works, as you've just seen. We've got our valves that we can switch between the different compartments in the boat, and both pumps are firing out the side there. And it comes out behind the wing so that if we're at a wharf or marina, it's not going to spray water across the marina and potentially get someone. It's going to hit the wing, which will always be up at a wharf, and then just go straight down into the water. Thanks very much, guys.